Now our software is open. Then let's take a look. Some interfaces on the remote control software. Like here in the upper left corner, there is a start collection. There is a start collection in the upper left corner, stop collection. Then there is an RGB channel behind it. This channel is for compositing. Hyperspectral image below is the color-only image threshold that synthesizes it. RGB threshold, it is to adjust the brightness and darkness of hyperspectral images. What we mainly set are some of the following parameters. The parameter here is the frame rate. Frame rate controls the acquisition speed of the camera. Generally, we recommend setting it to 60 or 50. Then the following exposure time. Based on the actual collection situation on the day, we have a diffuse reflective plate as standard. We are under the sun. Then collect the data of the diffuse reflector. When collecting, we were on the right side of the remote control. There will be a maximum consumption here. We want to guarantee the maximum consumption here should reach about 70%到80%. What we have here is a spectral merging and a spatial merging. This spectral merge, the maximum channels of our camera are 1200 channels. So after merging, there are 300 channels. Spatial merging, the maximum spatial resolution is 1920. After spatial merging, its resolution is 480. This is the height of this image. This height is the height of 480. Then import the wavelength later. Import here, the wavelength is when we leave the factory. This configuration file has already been configured. Below is the flight altitude. It is based on your actual situation. Our recommendation is below 150. 70 meters and above 80 meters. Then save the path. It is also configured at the factory. What is saved in it is the file folder of the D drive. This is the preview camera. Like the image we see on the right. It's an image from our preview camera. When drones collect data in the sky, we can see where the collection is in real time. Then save the image. It's us previewing the camera. There is a default program that runs every once in a while. Take a picture. He will save this photo. Later we have automatic exposure. Automatic exposure. It will be based on the weather conditions at that time. Automatically adjust the previous exposure time. The following language versions support Chinese and English. Then there is an enable correction at the back. Below it corresponds here to a lens correction. Lens correction, it means our camera. It is a line scan mode. Our lens is round. The semaphore is relatively high when it is in the middle. When it's on a round edge, it will be a little darker. After this correction, we will put this. Eliminate the effect of dark edges. This coefficient, it is also configured when we leave the factory. We don't need to modify it later. The above parameters are our some parameters of basic settings. Now let's look at the right side. Here is some status information on the right. Camera connection status, drone status information. Then the bottom is a little blocked. Here is a shooting mode. An airplane mode shown on the back. Further down is a collected frame rate. That's when we were collecting. The frame rate we set here. It will be displayed here in real time. Then the last one is maximum consumption. Then let us take a look at the bottom parameter. It's right under our camera. It will have a row of parameters that are flight speed. Then fly height resolution. In terms of resolution, it is based on the merger we made above to calculate it. Then there is a focal length behind. The focal length is standard for our lenses. It's a 25 毫米 lens. The remaining disk is our built-in supply and control machine. It is a Windows system. How much is left on his disk? It's us who are saving the data. Dislike once and save once. This reminds us. If the remaining disk capacity is insufficient, we will delete old data promptly. Then wait. Save data. That's when we were collecting. When collecting, he collected and preserved at the same time. He is here to save the remaining quantity. As mentioned before, here is a flight speed. It is based on our parameters above. Frame rate, number of spatial binning. Then the flight altitude. It is calculated based on these values. A speed. So our drone is taking aerial photos. When arranging a route, our speed, it also has to match our flying speed. If the speed is too fast or the speed is too slow, will cause our image to stretch or compressed. Then the flying height behind, it is also based on our above. The flight altitude is set above. Our software interface contains these parameters. We can do it in our remote control. Quickly set these parameters. For example, if we are in the upper right corner, there are 3 dots in the upper right corner. After clicking it, here P is above. There is a PSDK here. Click this interface. These are some parameter setting interfaces of our fixed spec. Let this display real-time data from above. Open this button. Here will appear a small window. We can see this in real time. A current state. A software connection status. Then collect the status. Just a maximum semaphore here. This is the collection I just mentioned. Used when adjusting exposure time. Recommended flight speed here. It is also shown here. Then we open the PSDK. Here is a start collection, stop collection. We can demonstrate. Click to start collection. After starting the collection, the images we have here were collected indoors. It consumes very little. Look, the current maximum consumption is only a few tenths of a percent. Then the spectral curve like the one below is also moving. So you can start collecting now. Then we stop collecting now. Now we have stopped. His curves have stopped moving. Then this upper left corner, he also shows a stop collection. The following parameter settings. Just some exposure values. Upscaling, RGB channels. RGB threshold. There is also a flight altitude. There is also a spectral merge. At the bottom is a preview of camera and lens calibration. Save preview camera. These parameters are what we often set. We are directly on the remote control. You can quickly set it up. If set, for example, we now set the exposure time to a large. Set to E1. Click on each of our parameters after entering the value. Please click the check mark below. In this case, only when we synchronize parameters can be. Step up if you don't want to. This parameter cannot be synchronized. Then we modify the frame rate. You can take a look. Right now our frame rate is 60. We can also see a 60 on it. Exposure time is 5000. We have now changed it to E1. Change the frame rate from 60 to 100. Then click the check mark. Let us demonstrate how to set these two parameters. Then we click a few more times to synchronize parameters. Then let's take a look here. Then the frame rate and exposure time will be changed. The frame rate was changed to 99. Then the exposure time is now 10000. Other parameter settings are also the same. Just before our drone collects data. Exposure time, frame rate, flight altitude, spectral merging. Spatial merging. These can be set. In the process of collecting data by drone, the data we just mentioned cannot be set, like exposure time, frame rate, and flight altitude. Spectral merging, spatial merging, these parameters cannot be modified anymore. During flight, we can adjust one of its RGB channels and RGB threshold. In this case, just like sometimes we are collecting water. Lake or green value. Semaphore darkland. When we look at the software interface, it looks quite dark. At this time, we can adjust its pre-value. If the image is darker than the picture, let's lower the threshold. In this case, it will make our images appear brighter. These are the parameters here, like spectral merging, space merging. It has the spectral merger I just mentioned. Are 1200 channels on the channel. Then after merging, 4 edges will be 300 channels. The combination of the two equals 600 channels. We can demonstrate. The two merges are before collection. Set up. Then after selecting, we click on the parameter synchronization above. Click a few more times. Like here we can already see, its spectral merging and spatial merging both become R. Then we will make preparations before arranging the route. We combine the four spectrally. Space merge 4 demo. Flight altitude is 80. The acquisition frame rate is 60 for demonstration. Now after I set the parameters, click Parameter Synchronization. After Parameter Synchronization, check if it is the parameter I want. Boost 60 Spectral Merging 4, Spatial Merging 4. Flight altitude 80. Then according to these parameters, he calculated a recommended flight speed of 4.5. Then we go based on our parameters here to plan a route.